Hello, and welcome to another Wolfram Tech Talk. I'm Arben Calzici, and today I'm joined by Etienne Bernard, a former physicist who worked here at Wolfram Research as the lead of our machine learning group for 7 years? 7 years, I believe. Is that right, Etienne?
Something like that, yes.
Give or take. Yeah. All right, well, why don't you tell us a little bit about what you're doing now and this machine learning book that you've written?
Yeah, okay. So thank you. Hi, Arben. So yeah, as you said, I worked at Wolfram for about 8 years, and developing machine learning tools, machine learning applications. Mm-hmm. And at some point, I wanted to kind of share the understanding that I got from these years of development about machine learning and into a book. And so that's why I wrote this book. And now I'm actually transitioning. I'm still a little bit tied with Wolfram Research. It's a soft transition, mm-hmm. But I'm trying to continue exploring making machine learning more accessible. So we kind of did that at Wolfram.
Absolutely, yeah.
I think we pushed what was possible, but there's still one last thing that it requires you to know a programming language. And so I'm trying to explore, how far we can go without programming language to allow people that cannot code at all to create machine learning applications as well. So we'll see. So I'm starting a company called New Mind to work on that. And I guess today I'm going to talk about the book, right?
Yeah, please do. I mean, it certainly seems like a challenging problem to help people who don't know how to program necessarily to develop machine learning applications. And
yeah,
I know, there are a lot of super functions and stuff in the Wolfram language to do with machine learning that I personally have used without knowing too much about kind of what's going on underneath the surface necessarily, that I found very useful. So curious to hear what you're working on now on this front.
Mm-hmm. Yeah, I mean, it's still very early, so we don't know yet how far we can push. I mean, of course, knowing a programming language, there's still things that will be only doable when you know programming language.
Of course,
you cannot replace everything, but my bet is that we can maybe 80-90% of it can be mm-hmm. done. But at that point, it's very early. We're just starting. We're focusing on natural language processing first. These are things that I think more easier because it's kind of same thing, same preprocessing, same method, and so on. To tackle more random application, that's going to be more challenging.
Certainly, yeah. All right. Well, you've written a book here, right?
Yeah.
It kind of helps get us started on this topic. So why don't you tell us a little bit about this book and kind of what the purpose of this book is in furthering this goal you're talking about kind of making machine learning more accessible.
Okay, maybe I should share and show you the book. Actually,
please do.
I mean, it's not the book yet. It is it's a notebook, as you can see. That's
how a type of book.
It's a type of book, yeah. That's how I developed this book. I mean, that's how I wrote this book, mm-hmm. And. So yeah, it's an introduction to machine learning. So there's kind of 3 goals in mind. One is to teach you what machine learning is. Another one is to understand, what it does, what kind of applications you can solve with it. Mm-hmm. The second one is to teach you how to apply machine learning yourself. And the third one is to teach you how it works underneath, So a little bit more academic-y, this part. But I think that even if you have only one of these goals, I think this book is already useful if you just want to know what machine learning is. Mm-hmm. It's kind of separated these 3 goals, not to put complex things for people that just want to know how it, what it is or how to play a little bit with it without caring about, how whatever method works. I think one particularity of this book is that it uses the Wolfram language, and it uses it in for several purposes. One is, of course, to teach you how to do machine learning in the Wolfram language, but it's not just that. It's also to teach you the concept of machine learning using the Wolfram language. So It's
Right.
like
That seems
actually
like
quick.
a good vehicle for that because, you can work at a very high level. Like I was saying, I worked with, the classify and predict before, and those things will, they work in a way that kind of makes sense, even if you haven't gone and read a textbook about machine learning already. So it's a good way to start.
Definitely, definitely. Most functions in Wolfram language are kind of self-explanatory and very high level, and so it's a language that is closer to natural language than regular programming language. So I think that makes sense to use it in a book, a bit like how is it called? This pseudocode, but anyway.
Yeah.
Um,
Pseudocode that is actual code.
exactly. Pseudocode, actual code that you can modify, that you can run, and so on, play with. So typically that's how it goes. It's like a text and a bit of computation, so a bit of code, text again, code, text, code. So that's the function predict that you were mentioning before. This is to explain how to predict a numeric variable, and so on. That I think at Wolfram we call this a computational essay. Alternance of text and computation.
Yeah, text, computation, graphics, visualizations, kind of the whole shebang.
Yeah. Exactly. So that's kind of how it is. And so this obviously we will show you how to do machine learning, using predict, for example, and how to plot, to visualize your model and things like that. But then it's also about concepts. So if I look regression measure, so we could look at the mean squared error, for example, and usually to teach mean squared error, you put a formula like that. And it's very well suited for some people that know formula very well, but some others don't like it so much. This one is simple, but like even myself, as you mentioned, I did physics, theoretical physics. I hate big formulas. I don't know why. When there's too many indices, I hate it.
Yeah, and that's why we're in physics and not something else, right? We want to try and keep things simple.
Exactly. And so the alternative is to actually, let's compute the mean squared error from scratch. So first we make predictions, that's the predictions, then we compare this prediction to the true values, that's the residuals. We can show an histogram of the residuals, and then we can square them and compute their mean. And that's what the mean squared error is. So I didn't went all the way and remove the formula because I believe people, especially the one that are suited for formula, is great to have it.
Yes.
So I kind of do this double thing, like computations and math and visualization, of course. That I think everyone likes visualization.
Yeah, I think that's a really good way to do it because this is a little strange, but I saw this thread on Twitter where it was a computer scientist talking about how writing something like in Python or whatever it was, they wrote product as this variable goes from here to here of something, and they were saying this makes so much more sense than this thing with like this weird capital pi. I understand this so much better than this crazy math formula, even though it's the same thing. And I hadn't really considered before that people who might not have taken that math, if they'd learned it from a computer science perspective, it's a lot easier to do it that way for them than looking at this formula.
Yeah, exactly. I think it's not everyone will agree which one is better for them, of course, but but I completely agree with you that some people. So yeah, that's kind of what it is, and I guess I could go in the content later, and each chapter has like some takeaways, some vocabulary.
Oh, that's very useful to have a vocabulary section.
I realized I didn't realize that before. When doing the vocabulary section, I was like, oh my god, that's a lot.
I think it's useful. It's useful in general, but particularly with machine learning, when I've tried to learn about it, I found that there are just so many different terms that, they're very close to something that I know already, but they're subtly different in this context. So having a list like this is really fantastic.
And exercises, of course. I think this is kind of necessary to consolidate whatever you saw in the chapter.
Yeah. You can see these are some pretty, high level exercises for, just chapter 4 of an introductory textbook, right? Like, visualize.
It's on purpose. Actually, I always dislike the precise exercise about do this, do this, do this, do this. Then you're kind of a machine that can solve little problem, but you never manage to do the big thing.
Yeah, problems like that treat the user as a machine.
Yes, exactly.
It's a lot better for you to sit there and conceptualize about these things.
I think it was great, maybe, for the teachers, because then they can, it's not just you succeed or you fail. You can have intermediate thing and guide you a little bit. But I think it's not real life, so they're kind of open-ended as well. It's open-ended exercise. Like, the goal is not for you to succeed the exercise. The goal is for you to play with, to try stuff, to get on a notebook, try to run some stuff, try to have some success, and that's really the goal. Make you apply without necessarily getting the perfect answer. And actually, I didn't write answers for the exercise, and I don't think I will for this purpose. Maybe if too many people ask, maybe. So no, maybe I could go in the content.
I think a little bit. Things do you think are most unique and important about this text that you've written?
So, okay, I should go there. Maybe before, just to give you an overview. So the first two chapters, I mean, there's a short introduction to the Wolfram language, which is not enough for you to know the Wolfram language, but it's just a start. Then I think to take better advantage of the book it's better to, for example, read an elementary introduction to the Wolfram language or something like that, and you'll enjoy the book more. But you can also, with just basic understanding, continue reading the book.
Right.
Then there's two introductory chapters. So this is really for the what machine learning is. And I think this, very accessible. I think everybody can read that and understand, it's a bunch of examples, kind of like two main class of machine learning, in my opinion. The one that deal with images, text, audio, which are sometimes called artificial intelligence. Then there's some that are more about, tabular data, sort of things you find in companies that data scientists work on.
Yes, it's really nice because you have images. I saw a little audio snippet there. You've got text, numbers. You've got kind of the whole.
I try to make it
here.
as I love images. I try to make it as many pictures as possible. And this explains the main paradigm. So it's also very introductory chapters, what supervised learning is, what unsupervised learning is, clustering, anomaly detection, synthesizing the missing values, these sort of things. And then there's a few chapters, classification, regression, clustering, which are really task-oriented, like the function of Mathematica, actually. Dimensionality reduction, distribution learning. So it kind of these 4-5 main tasks that are detailed. So this is a bit more about how to practice machine learning yourself. And then, including data preprocessing, And then there's chapter 5, which is about how it works, how the name says. So
what here is it?
It is machine learning. It is machine learning, how it works.
How machine learning in general works.
Yeah. Maybe, okay,
nice
since
to
you
put that
asked,
in the
maybe
middle.
I should change it to how machine learning works. You're right.
I don't know. I'm not an editor. I can't make that choice for you.
The editor didn't tell me that it was a problem, but now that you mentioned, I will run a poll. So these ones are a little bit like, I mean, the one about the task are very example oriented. Car versus truck. Let's solve this problem. I don't know. Titanic survival. It's a very classic example. Right. Let's solve it. Let's do a bit of data analysis, blah, blah, blah. Let's do a bit of visualization. Let's look at the model we produced. Or topic classification. Let's get things from Wikipedia. Train a topic classifier. Analyze how it classifies things. And deploy, actually. There's deployment here, like how to deploy the model on the cloud, for example, and so on, image notification. And then this chapter is a bit more academic, what is a model? What are non-parametric methods, which are basically nearest neighbors.
I like putting that in the middle, like introduce people to some, specific applications and then say, by the way, this is what's going on. And
I had, I think you mentioned that. I had big mental fight about that whether I put this chapter in the middle or after all the tasks. And exactly what you said. I said, like, if I were reading this book, I would be happy to see classification and regression, but I would be like, how it works? How does it work? On the downside, this chapter got bigger than what it was supposed to be.
I've
It was
seen that
supposed to
happen.
be a sweet how it works in the middle, so for the most curious, and it kind of grew a little bit. And I wanted to put more how it works after, which I did, but it grew a little bit. So I guess if some people, are a bit scared about that, like they could jump it and continue reading this this section and maybe come back later.
Yeah, can read the pieces that they're interested in, maybe.
Yeah,
if they want to just get to the meat of it, get back to the meat of it, I guess.
Exactly. And then it goes deeper into the how it works here, which is the classic supervised learning methods. So you don't really need that to practice machine learning nowadays with good automated tools, but you may be curious, and it will make you a better practitioner if you know that. Kind of to be the expert practitioner is good to know this method. Yes. So explains what decision tree, for example, it's a very classic thing. What would be nice to show? Gaussian process, maybe. Gaussian process, what does this nice that models uncertainty pretty well. Actually, this one goes a little bit deeper into really how Gaussian process works. I don't want to scare anyone. This is like this is the hardest part of the book that explains actually how Gaussian process works. That is about Gaussian process is random functions and it conditions random functional data. So this is like, you don't necessarily need to read that or understand that to practice machine learning.
Yeah, but it's there if you need it.
It's there
if you're just interested.
Yeah. I end up making it a little bit more complete that was intended at the beginning. But I don't think anybody will be unhappy about that.
Yeah.
And these important chapters, deep learning methods, was probably the biggest chapter, actually. That's also, I didn't realize, but after doing it, I mean, of course, deep learning is a lot of things to say. And it ended up being a chapter that is like the size of 3 or 4 chapters. But
you can just sneak that in at the end there. Nobody will notice.
Exactly. So it's a full-on introduction to neural networks. Going from explaining artificial neurons to classic neural networks, and then explaining how they learn. So gradient descent, for example.
Oh yeah.
I went a bit down the rabbit hole, but
it's a good rabbit hole to go down.
It's a good rabbit hole. I think many would be interested. And this is also an example of a computational essay, actually, because to teach gradient descent, well, let's do it. Let's take a function. That's a function. We can visualize it, and then we can compute the gradient, and then we can do one step of gradient descent. You also have the formula if you want, but you have the code after, and that's one step to find the minimum. Local minimum in that case, I think it's going to go there, of this function, and then you can do it several times, and you kind of this trajectory. So
really instructive,
Yeah. So for those who don't know, it's an optimization method, classic optimization method, gradient descent. So this sort of thing, explaining back propagation. How you compute the gradient in a neural network.
Yeah, so anything anybody might be interested in with regards to deep learning here is kind of
covered in good detail. It's also more complete than I intended in the beginning, but and then it goes like particular architectures, convolutional neural networks, like let's see, 2D convolutions. That's operation that are in this network. It's network used for computer vision to recognize what are in images, like the object in images, for example. So it kind of explain what is a convolution procedure, and actually one neat thing, because you asked, is there some neat thing you want to show? Yes. I went down. It's not there actually. Where is it? Where is it? Model image classifier. Yeah, model image classifier. I went down the rabbit hole to explain, to try to understand what this neural network were doing. So this is a kind of a classic method. It's like feature visualization, and basically you ask a network what are the input that activates the most a given part of the network. So it's an optimization process. You move the input to try to make a given part of the network activate. And what's nice is that when this part of the network is low in the network, is in the beginning of the network, then you see these kind of simple shapes, these simple patterns, let's say, which mean that this part of the network is kind of understanding simple things like edges and objects. And then if you ask a little bit higher, you will see more complex patterns. So it's understanding more complex structures. And then even deeper. And at the end, you kind of see not exact object, but yeah, you kind of understand. I don't know. It's like close,
it's like building up these kind of deep dream-esque images.
It's very close. It's very close to the deep dream thing. So I had a lot of fun generating these images.
Yeah, those are really nice. Yeah.
Anyway, just a anecdote.
All right.
Part.
Yeah, that's pretty fantastic. All right. Well, when can folks get their hands on this book or notebook, as it were?
Hopefully in about a month.
Oh, that's pretty soon.
We are on the final stages. Yeah, kind of. Let me close that. Yeah, finish the last edits. Now it's the cover. That's the current cover you saw. Which I think is pretty close to the final. I like it. And yeah, they should be at some point. We'll put online version as well, and so you can have access to all the code. Because sometimes the code is hidden. That's something I didn't.
Yeah, I saw some iconize there.
It's not. I think in a book, there's like the options. Let's say, okay, that's the options for the visualization of this histogram. Like nobody cares about that, so I just hid it. But in the online version, you'll have access to all the code, nice. And even the illustrations. Actually, everything is done in the Wolfram language. So I don't know which one I should show, but like this one, there's no code at all because the code is actually hidden, and that's the code, which actually uses image bounding boxes which detect the object. So it does the object detection. Like this one. This one does the super resolution. This one does the translation. Like it's all I don't think I have a lot of fake. I don't think I have any fake illustration. Like it does the thing that it shows.
That's good to hear. Yeah.
And you can see the code in the online version. Probably the book is going to be ready before.
All right, that sounds good. Well, I'm looking forward to it. I think I'm going to have to give this a read because my understanding of machine learning, while it has improved over the last year, remains pretty rudimentary, I would say. So this looks like a really fantastic resource. All right, thanks a lot for your time, Etienne. Have a good one.
Thank you.
That was Etienne Bernard, our former machine learning lead, who has written a new book, Introduction to Machine Learning, which will be out, as you just heard, hopefully in the next month or so. And I personally am looking forward to reading it. So that'll be all for today. Stay tuned for more Tech Talks.